shall we begin?
Yes, sir.
Okay, fine. Tell me about yourself, Suma.
Yes, sir. Sir, thank you, sir, for this providing this opportunity for a mock interview. And I am Sumlata, and I have done my master's in VLSI, sir, from Indoor Institute of Technology in 2014. And after that, I worked in DRDO, sir, as a quality assurance engineer. And to acquire knowledge in VLSI, now recently I have done my physical design training from Siemens Private Limited. And I have done 4 projects, sir. One is full chip level and remaining 3 are block level projects. And tools which I have worked is one is Innovus and Genus. And technology is 45 nanometer and 90 nanometer technology. And I learned how to do floor planning, power planning, CTS and routing. That's it, sir. Thank you.
Okay. Where did you do your degree, like graduation, UG?
Graduation from L&K Engineering College, sir. Location is Siddipet, sir.
Okay. What was your engineering project?
Engineering project is smart card technology, sir. Toll gate using smart card technology. Whenever we no need to use the cash. So using by using the smart card, we can access the toll gate, sir.
That's already existing, right?
Yes, sir. Now it is existing, sir.
Okay, fine. When you thought of doing the project, was this existing?
No, sir. At that time, it was not there.
Okay, fine. Tell me about yourself, Shiju.
Hello, sir. Am I audible?
Yeah, you are audible, loud and clear.
My name is Shiju NP, sir. I'm from Calicut. I completed my diploma in Government College at Chalagra. After that, I go for the BTech through the laterally course, and I completed in my BTech in the stream of Electronics and Communication in the year of 2022. Currently, I am in under training on VLSI for our private limited. Currently, I'm ongoing, sir.
Okay.
That's
No. So, what did you do in your engineering project, like your BTech project?
sir, it's a guest control wheelchair using MEMS, sir. My final project.
Okay. Like, what was the area of working? Is it IoT based or embedded?
It's an IoT Internet of Things, sir. IoT based.
Okay, fine. So, what was the main aim of your project?
So main aim of your project, sir, the wheel to provide a wheelchair for handicapped peoples with only the he or she can control with her palm movements, sir. A accelerometer is over there and which can capture the movement of palm by the axis with the respect to the axis.
Okay. Fine. Okay. So, Suma, what are your expertise or what are your in which subjects are you good at in electronics?
In electronics CDC, sir.
Only EDC?
Yes, sir. Actually, I'm preparing for the basics of theory part of PD and basics of digital electronics.
Okay, fine. Whatever you are saying is okay. I accept it. But the thing is, see, you are saying that you are a painter. You are painting a wall. Okay.
Yes, sir.
Okay. That means you are painting a room. That means you need to know to paint a wall. You understood what I said? If you
Yes,
are
sir.
preparing for PD, you need to be prepared for the remaining other subjects which are linking to the PD, right?
Okay, sir.
And we'll move on. I'll ask some questions. I'll ask both of you one question, and I'll ask pick the names to answer. Okay.
Okay, sir.
What is a gate, Shiju?
Sir, gate means logic gates.
No, I'm just asking you to define a gate. What is a gate? with respect
Sir,
to electronics?
sir, gate is the part of a device which can give output with respect to how we can declare the gate. For example, it is the lower level of every device.
Okay.
Without gate, we cannot make any kind of device.
Okay.
If we put into an example and or something gates, the inside the gates there are MOSFET transistors. We can build a gate by transistors.
Sure
The
about
basic,
you can't build anything out of a gate except
sir,
excluding gate.
not like that, sir. We can build in easier way with the definition of gate, and also we can describe much easier way by using these gates. There are various function over various gates.
Fine. Suma, what do you mean by a gate?
Sir, gate is nothing but to perform any logic operation, we use gate, sir. By using logic inputs, zeros and ones. That's it, sir.
Then what do you do when you have to do an arithmetic operation? You said logical operations, right?
Yes, sir.
So if I have to do an arithmetic operation to add two numbers, 0 and 1,
Adders, we use.
binary arithmetic. I'm saying binary arithmetic.
Okay. Binary arithmetic also we can use, sir. Logic
And you
gates.
said only logic operations.
Yes, sir. But for binary arithmetic operations also we can use logic gates, sir.
Okay, fine then. What do you mean by flip-flops, Suma?
Sir, flop is a memory element, sir. Flop is a edge triggered, sir, and whenever the contents will be output will be remain same when clock edge is occurred, even if the inputs are changes, output will be constant, sir, once the clock is triggered in
Sure.
flop.
What about
Sir, flip-flops are basic building blocks of a memory element. We can store 1-bit data in a single flip-flop. If we want to put a big memory block, every memory blocks will be containing a flop, sir. And also clock is there. With respect to clocks, the memory, the flip-flop is working, sir.
So how does a flip-flop store a single element, as I said?
Sir, in 3 steps, I think it store a bit, sir. If you give input and with respect to clock, it will store the value, and after the next when we want that by that stored value, we can retrieve the value by another clock pulse, sir.
So you mean that so what's the main thing that's required for a flip-flop to store a element? Like on what basis it operates? One thing
It operates on basics gates, sir. It operates on basics gates and feedbacks.
Sure about gates. Where does the gates come in flip-flop?
Sir, the flip-flops are made up of either NAND or NOR gates, sir.
How can you say that either by NAND or NOR?
Sir, inside that
can be even the flip-flop can be a basic element, right? You are saying it's a basic element.
It's a basic element for memory, sir.
Okay, fine. I'll give you an example. How are D flip-flops made up of? You are considering SR flip-flop and you are saying that it will be made by either NAND or NOR. So I'm asking you, how does a D flip-flop will be made of?
D flip-flops are made of D flip-flop data flip-flops are when which data we will give, it will
I know that.
reflect
I'm
the
not asking about the function. How are it made up of? You said that every flip flop will be made up of NAND and NOR.
Sir, D flip-flop, we give the negotiated value using S and R. If you consider S and R flip-flop, the data will be passed to.
Okay, I'll ask you one question. Can a D flip flop be built by NAND and NOR?
Yes, sir, of course.
Fine. Suma, what's your comment on this? Can a D flip flop be built by NAND and NOR? NAND or NOR?
D flip-flop can be made up of... No, sir.
Oh, one NOT gate also.
Hold on. No, are you sure?
In the combinational circuits, we use logic gates, sir, whereas flops, clock will be there and registers and counters will be there.
I'm asking you to comment on this. Yes, if it can be built, then yes. If not,
No,
then
sir. No.
okay. Now you need to justify your answer. Why it can't be built by NAND gate or NOR gate, and if not, then with what elements will D flip flop be built?
No, sir. I have to go through it. I am not aware of it.
Fine.
What?
Okay. Now your turn, Siju.
Sir.
Yeah. Now you said yes, right? How? Justify the answer. Through
Sir,
what things you will start to build that?
things, sir, we can build the flip-flop, SR flip-flop by using 4 NAND gates.
Yeah, that's true.
Okay. By this SR flip-flop, we use one input as D, and the negotiated input from that D is given to either S or R. By we can made data flip-flop. It will work as a data flip-flop.
Fine, that's a good answer. Okay, fine. Then I'll ask the next question to Suma. What's the difference between a latch and a flip-flop?
Sir, latch is a level triggered and flip-flop is a edge trigger, sir. In latch, clock won't be present, sir. In the flip-flop, clock will be present, and in the latch, enable will be there, sir. And in flip-flop, by using clock, clock will be there, sir. And that's it, sir.
You said that in latch there will be no clock. Then how will it be a level triggered?
Sir, by using enable, we access a latch, sir. To
how? Explain in 2 lines.
When enable is in high, the contents, the output, the based on the input, we get the output, sir. Means if the input is changes, output will become change, sir.
Okay.
When enable is high.
How can it happen in a latch? Like if your latch is a SR latch, considering SR latch is there, if you are giving, how does it changes to output when you give an enable? We have to do some detailing in the enable, right? What for what enable, for what it will change, when it will change, how it will change.
Okay, sir. And if by using...
Fine, I'll give you an hint. Okay, you are providing enable to your latch. Okay.
Yes, sir.
Okay, fine. So for what enable will your latch operate?
What means 0 or 1, sir? Enable means.
So 0 or 1. What are those two called as?
One is high and one is low. Logic 1 is enable means logic 1 is enable, sir. So
That becomes another. Okay,
okay.
fine. That's positive logic you are saying,
Yes, sir.
right?
And
Enable high, enable low.
yes, sir.
If you
Enable high and enable low.
so for if your latch needs to operate on what logic will it operate? Like will your latch enable high logic or enable low logic?
Enable high logic, sir.
You can't operate on enable low logic.
No, sir.
Sure,
Sure, sir.
sure.
Sure, sir.
Okay, I'll put a bubble before your enable comes into your latch. What you will do that time? That time your latch will operate at the negative clock pulse, like
Yes,
negative.
sir. Negative level. Yes, sir. It's negative level.
You said just no. Okay, fine.
Yes.
Shiju,
Sir.
I'll give you an SR latch. You have to
Yes.
modify only two things to make it a flip flop. What you will do?
SR latch, sir.
I'm giving you an SR latch. You have to modify only two things to make it a flip flop.
I want to first of all put two gates, and in latch we have only two gates. Put into another two gates and bypassing clock signal, sir.
You said a latch has only two gates.
Latch with enables has four signals, sir. Four gates. If we put instead of enable, we put clock, sir. Clock with the negatives or opposites, it will work as a flop.
Okay, fine. Now I'll give one input, okay, at the positive edge. Okay, I'll give one input at the positive edge, and I want that input at the. When will I get the output? Like when will I get the output in the clock cycle? According to the clock cycle.
According
For
to the
input,
clock cycle,
whatever for
input
whatever
is
the
equal
input
to,
I'm giving.
sir, if we made up of a flip flop by using
I'll make it simple. I'm
using
giving
NAND gates, sir. If set there are two
wait,
operations, sir.
listen to me. I'll clear a question for you. I'm giving you an input for the D flip flop at first clock cycle, at first clock edge, active clock edge, positive clock edge. Okay. When can I expect the output? The same input which I have given. When can I expect the output on which cycle and where?
Sir, after in the first clock cycle, it will go through the flip flops, and the next clock cycle we can get the output, sir.
Next clock cycle means first or second or third or fourth.
If it is a positive edge triggered or negative edge triggered, with respect to that,
positive edge triggered. It's a positive edge.
then the next positive edge we can get the output, sir.
Next when? First positive edge or second one?
Second positive edge, sir.
Second. Okay, fine. Okay. What do you mean by propagation delay?
Yes, sir. I am aware of that.
Yeah, what do you mean by that?
Sir, propagation delay is the time in which the gate want to proceed the function, sir. If you give an input and want an output, the time is between the process take in between the gates. That's is defined as propagation delay, sir.
Okay. What do you mean by a delay then?
The delay is with respect to a gate, sir. To propagate the output, it defined as propagation delay by a gates. If you made of a ended circuit.
Just asking what is delay? Define delay.
Define delay with respect to anything, I don't know, sir.
Just define the delay with respect to gate.
Define the delay with respect to gate, sir. I think it's propagation delay and delay of a gate is same.
I'm saying, what do you mean by a delay? You said propagation delay. That's fine. What do you mean by a delay?
Delay, sir, is the output. We expected to make an output with respect to one time. Na? The actual output is came with another time. The difference between we expected output and the actual output can define as delay.
Then what do you mean by propagation delay?
Propagation delay is the time taken between take the process, which time they want to make the process.
So propagation delay and delay are both the same as per your statements.
Sir, inside that gate we have a transistor. Every transistor is work with the unique. We defined in a way that we expected to give some time with the output, but the actual transistor does not give the output with our expectations. Sir. That we can put into a delay. Sir.
Wait. What do you mean? What do you comment on this, Subha? What do you mean by propagation delay, and what is the difference between delay?
Sir, delay is nothing but 50% change in the input to 50% change in the output, sir. The difference, the time taken from the 50% change in the input to and 50% change in the output, that is delay, sir. And propagation delay, if there is a change in the output due to the changes in the input, then we call it as a the time taken for this, we call it as a propagation delay, sir.
Can you repeat what do you mean by propagation delay again?
If there is a change in the output due to the change in the input, so time taken for this, we call it as a propagation delay, sir.
So what happens in the delay? It won't have any changes.
If there is a change in the input, if there is a change in the output, sir, because of the changes in the input, then output become changes, sir. So
what do you mean by slack?
Sir, slack is a difference between required and arrival time, sir.
You mean to say that required and arrival time difference will be always a slack?
Yes, sir.
Then what do you mean by skew?
Skew is it's a delay difference between arrival of same clockage of capture and launching flop, sir. And
same clockage?
Arrival of same, sir, capturing path delay difference minus and capturing path delay, sir. Capturing minus launching path delay difference is a skew, sir.
What do you mean by skew, Shiju?
I don't know, sir.
Slack?
Yes, sir. Both are.
You don't know slack also?
Sir, actually, I know I studied, but not right now. I don't remember, sir.
Fine. What do you mean by rise time then?
So rise time is the time taken by the clock to input or clock to rise and 10% to 90% values.
So the what is value like? Complete your answer. You're saying like 10% to 90% time taken.
Time taken to rise the clock to rise time and fall time. Sorry, input I think.
Only input.
If a signal has came to picture.
Shiju, are you attending through laptop or mobile?
Laptop, sir.
Laptop. Then you might be having an access to whiteboard, right?
Yes, sir.
Explain me the rise time and fall time using your whiteboard.
Yes, sir. Sure. Sir, is it visible, sir?
No. Share your screen.
Right now, sir?
Yeah, now it's visible. You are using something.
I watch AMB protocol, sir, in YouTube.
Fine.
Sir, it's not like an actual clock.
I'm not able to see. You are sharing YouTube screen, not your.
I think I only use Chrome to share. Let me stop sharing. Sir, now, sir?
Yeah, now I can see.
Sir, it's our ideal clock, sir. Okay, actual clock is not like this. If we put into this to this time, it's defined as rise time, sir, 10% to 90%. And
so you are counting it from 10% to 90%, or you are counting it from 0 to 90%, or 0 to 100% between the time. From where you are
10 to 90%, sir, because the change is not instead, it is not that accurate. That's why we taken this from 0 to 100%. Just want a flat value, so that's why we taken to 90% to 10%. In between there is a change, that is change is not abrupt, so we take it as from 10 to 90 and 90 to 10 rise time and fall time.
Fine. Suma?
Yes, sir.
By clock.
Sir, clock is a oscillating signal with frequency, sir.
So any oscillating signal with frequency is called as clock?
No, sir.
Why?
Right, in clock signal, rising and fall times will be same, sir. In the normal signal, it won't be like that, sir.
Sure about it? Then what does the sine wave will be there? You don't have a rise time there.
Frequency will be there, sir, in the clock.
You said that rise time and fall time, right?
Yeah, yes, sir, but that is a different point, sir. Whereas in the oscillating signal with frequency, we call it as clock, sir, normally.
So oscillating signal with frequency is called as clock.
Yes, sir.
Okay. How do you define the clock's frequency?
Based on time period, sir, T is equal to 1 by F or F is equal to 1 by
I don't
T.
need formulas. I just need how do you define frequency of a clock?
It's a reciprocal of time period, sir, frequency.
I know that. Again, you'll
Exact definition I have to go through it, sir. What, how to define that?
Nice, sir.
How do you define? How do you calculate the frequency of a signal?
For calculation, I use the same formula as mentioned.
Just the by line, if you have to say that. Have you heard anything about? Have you both heard anything about number of oscillations?
Number of oscillations per second.
Number of oscillations per second, sir. Yes, sir.
What does that mean?
Frequency, sir.
Yeah, that's frequency, sir. If I want to put into calculation, sir, we can only make it through.
How do you calculate? How do you calculate?
By taking the time period. The definition of frequency is number of cycles per second.
That's what I asked for you. I didn't ask for the formula.
Okay, sir.
The formula is derived from this only, right?
Yes, sir.
Okay, sir.
Fine. Okay. I'll ask some questions for Suma. What do you mean by mux?
Sir, mux, it will take multiple inputs and give single output, sir.
How? How does it operate? How does it work?
Sir, it's by selection line, sir. If S is one selection line and inputs are I0, I1, then the output is S bar I0 plus S I1, sir.
Right. So how does it operate? Like you are saying that select lines input output. Yes. How does it operate?
I have to go through it, sir.
Same question for you, Shiju.
Sir, mux is a device which takes multiple inputs and gives only single output with respect to based on the select line, sir.
Okay.
That's we make by the Boolean expression what kind of output we want and go through the K-map, and inside of that mux we can
You
just
are going through calculations. No, I'm not asking about the calculations. How it operates? Just one example is enough. One line, one input. See, we are saying that 4 inputs are coming.
Sir, based on the select line, it will propagate the output. But it normally, if it comes into picture, if normally we use if I take an example, 4 into 1 marks now.
Okay.
If we normally selectants are 0, 0, 0, 1, and there are 4 combination. In the first combination, the I0 will select. Second combination, I2 will select. Third combination, that's our user choice, sir. If you want to select a first line with respect to 1, 1, that also we can make, sir.
How can you do 1, 1 by selecting first line?
I think it's by changing the changing inside the gate functions. I don't know, sir.
Very
Just
close to the answer and you just went back. There are 2 ways to do that. Try. How can you give? How can you select I0 using 1, 1 combination?
I0 using, sir, normally I0 is comes with 0, 0, 0, 1 is gives IC, I1, and
now you
like
want
that.
to select I0 with 1, 1 combination.
I0 with 1, 1 combination. If you put into select line with the NOT gate, we can simply.
What's the other way?
Otherwise, I want to check, sir. Functionality is changing. We can anything we can make.
You just need to put I0 to the 4th position. That is I3. If you put there I0, you will get I0.
Yes, sir. That's changing, sir.
Right.
Yes.
Okay. How good both of you are in MOSFET theory, like MOS theory, CMOS theory?
No, sir. No.
Give Suma.
MOSFET theory. I'm also, sir, and it's not that much. 100% I can't.
Fine. Okay. We'll ask a few questions. Let's see. What's the formula for channel creation, like in enhancement mode MOSFET?
Formula for channel creation, sir. Something that.
You, Shiju.
I don't know, sir. Actually, I studied, but not now. I don't know any equations or so kind of things.
Right. Then difference between MOSFET and BJT?
Sir, BJT is to tell me, I say current control device, sir. But MOSFET is a voltage control device, sir.
BJT is current control device.
BJT is the collector current is with respect to IB, sir. IC is equal to beta times IB, but in MOSFET it is a voltage control. The gate terminal voltage will control the output current.
So you're saying that MOSFET is a voltage control device.
Yes, sir.
How?
Sir, based on the voltage, sir, and enhancement, if we take an enhancement MOSFET, sir, the channel creation will done with respect to the gate voltage, sir.
Fine. How does the channel gets created in the MOSFET?
Sir, when goes to the theory of substrate, there are p-type and n-type substrate, and inside that work, if we take a p-type substrate, it will create a n-channel by the two layers. It actually is working like that, depend upon the voltage that we give.
Fine. Suma?
Sir, BJT is noise is more, sir, in BJT, whereas in MOSFET less noise will be there, sir. And in CMOS power dissipation will be lesser. And
I'm not going to CMOS. I'm just asking the difference between MOS and BJT.
Okay, sir. And BJT is a current controlled device, sir. And why? Because the two terminals, current flows between the two terminals will be controlled by the other terminal, sir. So it is a current controlled device. And
what happens with the MOSFET? What will control what? How will it be controlled?
It is a voltage controlled, sir. Why? Because gate voltage is passing towards drain. It will turn on, sir. It will act as
How will it
enable, sir.
No. How will it turn on?
By applying voltage to gate, it will turn on, sir.
Yeah, what it will turn on? The device is already turned on, right? Or there should be a condition to turn on your MOSFET. So if you provide gate voltage, what will happen? How will it turn on?
If the voltage is passes through gate to drain, it will turn on, sir.
Shiju, can you answer this?
After the threshold voltage, only we can create the channel, sir. After the threshold voltage.
So what happens when the channel is created?
The channel is created, the current flow we can control with the, I think it's the, make it in the width of the channel or something, we can control. After the threshold voltage only, the channel will create, then we can only control the current.
What do you mean by turning on the MOSFET?
Turning on the MOSFET is, if the voltage met the upper than the threshold voltage, then the MOSFET will turn on, sir.
So creating a channel is the turning on the MOSFET, right?
I think for a enhancement MOSFET, sir.
Yeah,
different.
I'm talking about enhancement.
Yeah, enhancement.
So the turning on the transistor means, MOSFET is giving creating a channel. Fine.
Yes, sir.
Okay, we'll go to PD now. What are the inputs for PD, Subha?
Sir, dot lib and netlist, sir, gate level netlist, dot lib, dot left, dot HDC, sir.
So what does dot lib contains?
So dot lib is a physical library, sir. It contains cell delay and cell functionality, input transition, and power details and output load capacitance, PVT conditions.
So only dot lib is only a physical library, or does it have any other libraries in it?
Only physical library, sir.
Fine. Then what do you mean by .tf?
.tf is a it's a which contains a metal layer information, sir. Minimum width, minimum spacing, and TF file comes from Foundry, sir. Metal layer and bias information will be there, sir. Physical information.
Fine. Then what do you mean by the floor planning?
Sir, floor planning is a process of planning of placing the macros and planning of our core area, sir. Placing of macros.
Only macros?
Yes, sir.
Okay. What are the guidelines for macro placement, Shiju?
I'm not from PD, sir. I don't.
You're not from PD?
No, sir.
Then what are you like? What are you getting trained for?
DV, sir.
DV. Okay, fine. Then some questions might not be relevant for you. Fine. We'll go ahead. Okay. Suma.
Sir.
Guidelines for macro placement.
Sir, macros should not be placed center of the core area, sir, and it should be placed.
Why not?
Sir, for routing, sir, congestion problem will come. If we place at core boundary, we can easily routing will be easy, sir, and we can avoid congestion problem also, sir.
Okay, then.
And whereas stacking macro should be placed side by side, sir, and macro spin should be towards to the core area, sir, and orientation should not be R90 and R270, sir. And good floor plan is one of the best technique to avoid congestion, sir.
So, have you heard anything about fly line analysis?
Yes, sir. Fly line analysis, it's nothing but it's indicate the connections between the macros, sir. So, by using fly line analysis only, after fly line analysis only, we can place the macros. Whatever the macros macros connections are there, those macros will be placed, sir. Side by side and nearby, we need to place it, sir.
Okay, what do you mean by hard macros and soft macros?
Hard macros and soft macros. I have to go through it, sir. I learned, but I am not able to recollect it, sir.
Did you do power planning?
Yes, sir.
What do you mean by IR drops?
Sir, whatever the input we are giving, at output we won't get the same voltage, sir. For example, if 5 volts we are getting, at the output if we get 4.7, 0.3 will be the IR drop, sir.
So how do you define that? Where did that 0.3 go?
In the net, sir. For longer nets, this problem will come, sir.
Which nets?
Routing tracks. Nets
Tracks.
Means nets means, sir, from one standard cell to another standard cell, there will be nets will be there, no, sir.
How many metal layers did you use in your project?
9, sir.
Define what does each metal layer assigned for?
Sir, top 2 metal layers for power routing, sir.
Okay.
And middles are for clocking and for clock, and remaining for signal, sir.
Give numbering for them, like top 9 and 8 are for?
Yes, sir. 8 and 9 for power, sir.
Okay.
And
What did you pass through 8 and what did you pass through 9?
VDD, sir, means for horizontal it's VDD, sir, and vertical VSS, sir.
Okay. Then
8 is vertical and 9 is horizontal, sir.
okay. Then 6, 7.
Next is 6, 7 used for a clock, sir. 6, 7, 6, 7 and 5 also, sir.
Okay.
5, 6, 7 for clocks and 3, 4 for signal, sir.
What signal?
For signal lines.
You assigned the routing area only for 5 and 6. Sorry, I mean for 3 and 4. You dedicated entire metal row for 4 and 3 and 4.
Metal.
And what is metal 2 and metal 1 contained?
In the lower standard cells will be there, sir. In the lower metals.
Which one?
For signal routing, we used, sir, lower metals.
You use signal lower metal for signal routing.
Yes, sir.
Okay, fine. What happens why can't you route the power routings at the lower metal layer? Why did you route at the higher metal layer?
Sir, to reduce the IR drop, we use top layers, sir. Top layers has.
What happens if you route it at the lower metal layer? How does the IR drop increase?
Sir, width is more, sir, for higher metal layers. So width is more means resistance is lesser. So IR drop will be lesser.
So what happens if you go to the lower metal layers?
If we go for lower metal layers, IR drop will become more, sir. If we use for power.
No,
resistance will be more. Resistance will be more. Width will less. Width is less and resistance more. IR drop will more, sir.
Okay. What happens if I use multiple vias? Why do we use multiple vias?
Vias in general, it's used for connections, sir. Poly connections, metal connections, sir. For one metal to another metal. For interconnection, we use vias, sir.
So, what happens if I use multiple
from lower metal layer to from higher metal layer? If we want any connection, we use vias, sir.
Yeah, you can use single, right? Why do you use multiple vias?
If we use single via means only 2 connections will be there, sir. So multiple, if we need from, sir, sorry.
I'll explain a scenario for you.
Okay, sir.
You said that as per you, I am using 6 vias on third and second metal layer to connect both of them. I'm using 6 vias.
Okay, sir.
Okay. Now I'm using 6 vias. Why do I use 6 vias instead of 1?
Instead of 1. Maybe it requires more places to connect the metals, sir. That 2 metal layers required to connect in more places.
One is enough.
Okay.
Why do you use? See, if you place one via, that's enough. But if you place multiple vias, there's something that's going to happen. Why do you use multiple vias? We use multiple vias. Why?
Okay. Sir, in via, if only single poly will be there, sir. In multiple vias, if we use if we in single via, if it may get damaged. So in multiple vias, it can be.
You're not getting it. Fine. We'll move next. Did you do CTS?
Yes, sir.
what are the patterns or what are the types that you used in your CTS?
H type, sir.
H type. Okay. What are the methods of synthesis did you try?
Synthesis, sir.
Like CTS, clock tree.
Okay.
What are the methods? Like you said H, okay, fine. That's a pattern. What are the methods used? Which type of synthesis did you use? Like clock synthesis did you use?
Which type of clock synthesis? We need to propagate the clock with minimum insertion delay. Generally in CTS, what we have.
That's not what I'm asking.
Yes.
There'll be like CCD, concurrent clock design, classic clock design. Which one of these did you do? Okay, fine. I'll ask you another way. What was the main intention of your CTS?
Main intention of
CTS. Doing
Sir,
CTS.
to propagate the clock to all the flops, sir, in the design, and with minimum insertion delay and minimum skew, sir.
So you focused on
Minimum insertion delay and minimum skew, sir. Balancing the skew, sir.
skew, right?
Yes, sir.
Right. So that comes under classic method. Okay, classic clock design.
Okay, sir.
Classic clock. Okay, clock tree synthesis.
Okay, sir.
Then comes the slack. When you focus on slack, that comes with the concurrent clock design. Follow it. Okay.
Okay, sir.
Okay. What do you mean by a standard cell? What does it do? What does it contain?
Sir, it's a combination of all logic gates, muxes.
That's it. Contents of.
Yes, sir. Logic gates and mux, transistors.
It's made up of a transistor, right? How can you say that it consists of a transistor?
Made up of yes, sir. Made up of a transistor, but it contains logic gates, muxes.
Have you heard anything about G cell?
Yes, sir. While calculating the congestion, tool will divide the core area into G cell, sir. So based on that, tool will calculate the congestion, sir. Each G cell having different congestion values, sir.
Why does that happen?
To calculate the congestion, sir, tool will divide that, and generally congestion, if the required tracks are more than available tracks, congestion we get congestion, sir.
Okay, I'll share a whiteboard. Are you able to see the tab?
One message.
Can you see the tab on my screen?
Yes, sir. Yes, sir.
So I'll give you a practical question.
Okay, sir. Okay, sir.
You have a macro here. There's a standard cell here. Okay. So this macro is communicating with this G cell, standard cell.
Okay, sir.
Okay. So what happens in the legalization process? Do you have any idea about legalization process?
Yes, sir. standard cell VDD VSS should match rail VDD VSS, sir. So tool will do the legalization
Okay,
after
fine.
placement.
I'll come again. Okay, fine. What happens in the process of second placement? What happens in the placement stage?
Sir, in the placement stage, standard cells will be placed in the core area, sir.
Okay. Only that happens. There will be
Yes,
two
sir.
passes, right? You have run two codes, right? First pass, second pass when you did the placement.
One is
You have gone through the codes?
no, sir. That
Okay, there will be two parts. First pass, what happens? You place your standard cells.
okay, sir.
Okay, where will you place your standard cells? In the core area.
Core area, sir.
Okay, if this standard cell is communicating with this macro, then will you place this here or will you place this near to this?
Near to that macro, sir.
Okay, fine. Here you are placing your macro. Fine. Okay. Now what happens is that what happens in the legalization process? Tell me. Do you have any idea about legalization process?
Sir, legalization process is tool will flip the standard cell, sir. VDD, if VDD, it should match the VDD VSS of a rail, sir.
Fine.
So
that will be
based
one
on
thing. What are the other things that it do?
only that one thing I am aware of it, sir.
This is one G cell, right?
Yes, sir.
This standard cell will move to this G cell. So
Okay,
this calculates an congestion number. For example, 2. Assume this as 2. Because this needs to, the routing needs to take 1 block, 2 block and come here to talk to this standard cell. Then what happens? If here it was 3, because it used to change 1, 2, 3 G cell. Now,
Okay,
in legalization, this will be moved towards the macro, as close towards the macro. So this standard cell will move from this G cell to this G cell, this G cell to this G cell. Some standard cell will be covering only in 1 G cell. Some might be covering in 4 G cell. Some might be covering in 2 G cell. It depends. So it will move as close to this. So the congestion will reduce because of the routing length. Understood?
Okay, sir. Thank you, sir. Understood, sir.
Fine. I'll pick the question now. So you have placed your G cell there, okay? So now you are getting, after doing this thing, you go back and check the IR drop. You are getting too much of IR drop. What are you going to do? Or are you going to reduce that?
Okay. Yeah. Decap cells, we can use it, sir, to reduce IR drop. Decap cells.
What are decap cells?
Sir, decap cell act as a capacitor, sir. So by placing the decap cell, we can avoid IR drop, sir.
Till what extent can you do that? Fine. I'll ask you one last question. What do you mean by antenna effect?
Sir, during the plasma etching process, due to excessive accumulation of charges, gate oxide may get damaged, sir.
You mean to say charges?
Yes, sir.
How can the charges get settled, right? After the plasma etching?
Sorry, sir.
During the plasma etching, after one stage of etching, the charges get settled down.
Okay.
Okay, continue. You tell me.
During planarization, due to the planarization, due to accumulation charges, gate oxide may get damaged, sir. The whole process we call it as antenna effect. And to avoid this, we can cut the metal and if, for example, if the problem came in the metal 2, we can cut that metal and use the metal 3, sir. And also antenna diode, one of the technique, and metal hopping is another technique, sir. And generally antenna sir, antenna ratio is metal area by gate area, sir, we call it as. So if antenna area is more, we get antenna violation, sir. To reduce that, metal area we need to reduce, and we need to increase the gate area, sir. Adding antenna diodes is one of the technique, and metal hopping is one of the techniques, sir.
I'll give you one more question. This is a metal 7, this is metal 6, this is metal 5. Okay?
Okay, sir.
Okay. For example, consider this as 1, 2, 3. For example, just for example.
Okay, sir. Okay.
Now you have a antenna effect at this part.
Okay, sir.
Okay. You said that you will cut this metal and you will connect this to this and connect this to this and make a path. Okay.
Yes, sir.
If not, then you will insert a diode. Okay. So as per your words, you said that we will do the whatever during the plasma etching.
Hello.
Yeah, I can hear you. Yeah, I can hear you. Yeah, okay, you said that during the plasma etching, the charges will come and damage the gate area, right?
Yes, sir.
So my question is that the plasma etching doesn't happen at once, right? So once the etching is happened, they will leave some certain time to settle down, right? The charges to settle down.
Okay.
So if the charges are getting settled down, how will they damage the gate area?
Sir, if the voltage, whatever the voltage is coming, it's more than the threshold voltage, it may, our gate oxide may get damaged, sir.
Okay, how do you set the threshold voltage for that? You don't have any gate voltage provided, right? Or any channel creative, the voltage required to create the channel, you don't know what's the threshold voltage.
But we are aware of it, no, sir. The minimum voltage is required to turn on any gate. We call it as threshold voltage.
We can set the minimum voltage to higher level also. We can use, have you heard of HVT cells?
Yes, sir.
Then at that time, your metal won't act the same because you will be, your threshold voltage will be high, even though if you have sending so much of charges or so much of gate voltage, you need high voltage to turn on. And the SVT cells, a lot of SVT cells.
Yes, sir.
At that moment, even a negligible amount of current can damage your gate. How do you define these two?
Sir, HVT means if we required more voltage to turn on a gate, means it's very slow, sir. The operation become very slow.
I'm saying with respect to this thing, you said that charges can come and damage the gate oxide.
Yes,
so
sir.
If you have a HVT cell here, it can't damage, right? As per your words, you said that the threshold, if the voltage is whatever the voltage that coming is more than the threshold voltage, it will damage the gate oxide.
Get damaged. Yes, sir.
Yeah. So if you have a HVT cell, which is, for example, if you are having 3 millivolts as a gate voltage or threshold voltage, and if you if your voltage what are coming from here is 2.5, it won't damage, right? It's just a negligible current for voltage for this 2.5 volts or 2.5 millivolt or something, whatever the voltage you are saying. So that time it won't damage, right?
Yes, sir.
Then you said something wrong here. Fine. Okay. We'll stop this here. You both needs to recall, especially Suma, you have to go through a lot of PD. I
Okay,
know
sir.
you have understood everything you have gone through, but go through some minute details. That's where they are going to catch you. Every interview going to catch you at the minute details. They'll drag you, even though if you are full confident and if you know everything, they'll hold that thing and drag you. And if you don't know something, if you are not confident about something, just say that I don't know and skip. That's better than to get trapped. Okay.
Okay,
And
sir.
Shiju, you are very good at basics. Refresh those things because you have to go through the basics repeatedly so that they get settled in your brain. Go through some combinational circuits, go through some digital basics, combinational and sequentials also. The thing is, you have to work on your verbal areas so that you can deliver your answer very confidently and clearly. The thing is, you can deliver your answer, but that won't convince the interviewer because you will say your answer, but it won't be up to the point. So the answer is not to the point, or for the it's not like if it's not justifying for the question, then they might consider it as a wrong answer. Only few people who are patient enough to understand your wordings and all, they'll take it. Okay, so it's okay if you speak slowly also, that's fine, but try to form a proper sentence and answer in a proper verbals. Okay, use proper verbals and answer them. Okay, take your time and answer. That's okay. And you have to work a lot on digital, a lot from the basics to this. Start with the digital, go with the basic circuit, gates, definitions, logic, everything, and then go with the try to look for some interview questions about digital and all. Then with the PD, work on PD from the basics, and try to understand what did you do in your project. Have an interaction with the people who had done the project along with you, because some things that they have looked into the project might not be came to your view in the project also. So go with them, understand, try to look into those questions and all, and get it. Okay. And the other thing is, Shiju, you said that, Shiju, the thing is, you are attending through laptop, right? So always try to make sure that there's enough light, okay? And at least and try to see, I know your background is not good, but try to use these filters. Even my background is not good, but I've used some filters so that look decent.
Yes, sir. Regis sir just told me to go through it suddenly, sir. Just 1 minute before I know I have internet.
It's okay. You can take a time at that time also. The interview will wait, but not for too long. Just a minute and 1.5 to 2 minutes. 2 minutes is fine. They won't wait for long. Okay. Always try to be in a proper posture. Don't lean forward or don't go back. Right? Okay. Because that will give the first impression for the interviewer. Okay.
Yeah, sir.
Okay, work always on clocks. Okay, for both of you, you both need to work a lot on clocks, because clock related, I mean sequential circuits will be the most asked parts in digital, and then they will go to some CMOS theory, and then they will go to your domain related questions, like if it is for DV, and if it's for PD. And in PD I haven't even touched the STA part. For sure they are going to ask you STA, the setup time, hold time, setup slack, hold slack, or what are multi-cycle paths, what are false paths, everything. They are going to touch everything. Be prepared for that, okay? And even you might also, for DV, they'll ask you about multi-cycle path, false path and all. You also have to be prepared with that, okay?
Yes,
Fine. If there are any questions, ask me. If not, then we'll end the session.
No, sir.
Okay. Nothing, right? No questions?
Sir, that via, you said no, sir, multiple vias.
That's because that reduces the resistance.
Okay.
What happens if you use resistors parallelly? What happens if you use resistors parallelly?
Resistors parallelly means it will reduce resistance, no sir?
And allows the currents to flow easily, right?
Yes, sir. Yes.
That's what happens. If you are connected third and second metal layer, if you have a wire in between these, if you have multiple wires, the current flows through, the signal flows through all the wires and it gets to the metal too. So the flow is becoming easy here. For example, if you have two pipes, first pipe and second and third pipe, if you have one tap between, one connection between them, to flow 2 liters of water, it all have to go through this pipe only, and it takes 2 hours to fill, come to this completely empty. If you have 4 connections, it would take less time.
Okay, sir. Got it, sir.
That's just try to analyze resistors, networks, and all resistors, like the network theory, resistors, diodes, everything, capacitors, everything by the water formula, tap and water formulas.
Okay,
Consider
sir.
current as a water,
Okay, sir.
taps as a diode, and taps as BJTs, pipes as the lines, that means the channel. Okay, that will help you understand.
Okay, sir.
Any other questions?
Sir, in the mux, in a 4 to 1 mux, you will say that only the functionality will change when we can get I0 from 1-1 combination. Only way get the I4 for to the place of I0. Na?
Wait, I'll explain that thing just in a simple way. Sorry. Yeah. See, the thing is, you said mux, right? Yeah, mux. I'll consider 4:1 mux. Okay. You are giving I0.
Yeah.
I1, I2, I3. This is 0, 0 you are giving. You have S0, S1, for example. Okay.
Yeah. So,
not
fine, sir.
Okay, and this is why. So I'm saying that for 1-1 combination, write everything. See, if you go by this one, you will get I0 here, I1 here, I2 here, I3 here.
Yes, sir.
Okay, if I want I0 to be at the 1-1 combination, if I want I0 here, what will you do? I'll just give I3 here and I'll replace this one with I0.
Sir, we can I clear with that, sir, but we can also done with the changing the functionality of internal circuit.
Yeah, you can do that. You can do that. This is the simplest way. See, whenever you have to go with the function thing, you have to find the simplest way. That's why they are going to pay you. If you are going to complicate, why will they pay you salary? Right? You have to find the simplest way to get a solution for the problems. If you find a difficult way, why will they pay? No. Do you want your life to be complicated or simple?
Yes, sir.
Simple, right? Always try the simplest way, easiest way. If there is no provision for that thing to do, you can try the other way.
No.
Okay, sir.
Fine. Any other questions?
No, sir.
No, right?
No, sir.
Fine. I'll end the session. Prepare well, okay?
Okay.